3-page handout. The first page is the description of the code, and we only use 6 different kind of code: G0, G1, G2, G3, and G90, G91. Is that one I want? And the second page is the code. The third page is a drawing. And this drawing house, so the second page, the code, is the code to create the house using the CNC machine. So before we discuss the specific code, let's look at how we control the machine. So this machine initially was a manual machine. So right now I didn't turn on the controller yet. So you can run like a manual machine. See, I can run this the x-axis horizontally, and I can run this axis in and out. That's the y-axis. The z-axis is this one. And this we call a spindle. The spindle is the main motion of the machine, so it rotates. And usually to carry a tool. So right now I replace the tool with a pen. So it's safer since we don't remove any material, but it also do the job of give you sufficient training on running the CNC machine. That's a typical tool that's used in a milling machine. Do you know what's the name of the tool? This is the end mill. So this machine is called a milling machine. So the operation is run. The primary operation this kind of machine is milling. Although it can also do drilling and do tapping, and also some facing, or depending on what type of tool you put it on. And it's called end mill. So this is the most versatile process for machining. For instance, you can make mold, like those very accurate mold to do like a die casting mold or injection molding. You need a mold, and the mold usually have very sophisticated cavity or geometry, and this end mill is able to create very complex 3D-dimensional surface. And all you have to do is to figure out what the trajectory the tool should go to create that 3-dimensional surface. So the trajectory is 3-dimensional. You can control the x, y, z 3-axis simultaneously to create any curves in 3 dimensions. And along with the fast rotational motion, so all these axes will run together to create the desired geometry. And in our lab, we don't actually move the z-axis. We do move it, but only when it's right on the paper, we're going to draw the figure that you want. But sometimes, for instance, you just finished draw the outside house, you want to go ahead to draw the circle, then you want to lift up the pen, right? If you put the pen still on the paper, you come to the top of the circle, you will leave a trace that you don't like it to be there. So you lift up the pen, then you go to the next spot and drop the pen and do the second geometry. So this is the manual operation. We can also control the motion by using the controller. This controller is a retrofit controller. This controller actually controls the output from the amplifier, this amplifier box. The amplifier will generate current, which will feed into this motor, AC motor here. That's called a servo motor. The servo motor compared to regular AC motor, the main difference is this servo motor actually receive feedback. They know exactly what Well, each axis is located. Like this motor is y-axis, Y motor. So the Y motor, the current come into the motor, well, depending on the commands that the controller send out to the amplifier, it also the controller also receives some feedback, like what the current y-axis is located and what the commanded location is located, and so they can compute the distance, and also based on the specified feed or the speed, they can send just enough current to drive the machine running at the exact right speed. And on this screen, we can see the coordinates for all the three axes, x, y, z. So right now it's in the unit of inch, so all the number representing inch. And it's measured from a specific location. And in this case, it's actually right here. It's at the lower bottom of the house. I set that to be my 0. You can set any location to be a 0, but when you're really making a part, usually you have a specific location you want it set to be your reference point. And all the coordinates is measured from there. Let's move the machine to show in the manual mode how we run the machine. So I just turn on the servo motor. So the controller, I gave it to the controller now. Now I cannot manually move it. It's been locked. So the controller is taken over by the motor. So I can only move the machine by control the rotation of the servo motor. And the motor can be controlled by this knob controlling which axis I'm controlling right now, X, Y, Z. X-axis, you can make it move in either positive or negative direction. And also you can make it run in increment or step motion or continuous motion. The speed is continuous motion. Rapid is rapid motion. So let's see what rapid motion looks like. So that's about the fast move in the x-axis, and this is the positive x direction. So intuitively, if I want to set up a coordinate system, if I'm facing the machine, x should be to the right, right? If you create a drawing, x positive should be right, y positive should be forward, right? Z positive should be up. And that's right, but you should actually, from the standpoint of view of the tool. So imagine you're standing right on the workpiece, fixed. Suppose the workpiece is fixed, it's not moving. And with the fixed workpiece, how the tool is moving. The tool is moving to the right, it's positive. The tool is moving forward, it's positive, Y. And that's exactly how this was defined. You see, the table is moving to the left, that means the tool is moving to the right, to the workpiece, respect to the workpiece. Similarly, for the Y, if you want the tool to move forward with respect to the workpiece should move backwards. Right? That's how it's defined as Y-axis positive. And the Z-axis positive is going up because the tool is attached to the Z. So that's right. And I'm going to change to the feed mode. So that's a continuous mode, but it's running at the specific feed or speed. And this speed is usually smaller than the rapid motion. And then if I go to 110, these three levels representing a step motion. 100 means 100 times of the basic unit, basic length unit. Let's look at one basic length unit, how long it is. Let's move to 1. And let's move the Z-axis. You watch the coordinates of the Z. I hit it once, then it's going to just go one step. Actually, I hit twice. So you see two movements, that's one step. One step is 0.5 thousandths inch. So if you just try to use your naked eye to watch how much travel it made, you cannot see it. It's 0.5 thousand inch. And for what about x and y? Let's move the y here. It's only 0.1 thousandth inch. So the x and the y is more accurate than the z-axis. The z is, so x and the y is actually 5 times more precise than z. So the smallest distance this x-y axis can differentiate is 0.1 thousandth inch. So, and when you use the lathe, I would ask you to do the part with dimension tolerance of 5 thousandths. So 5 thousandths for machining is considered to be pretty loose tolerance. So you should be able to easily achieve that kind of tolerance. But for CNC machine, that's too loose. You cannot assign tolerance that big. Usually you have to assign it to be more accurate. So that just gives you an idea about how precise you can set the distance or set the dimensions. So, but actually the real accuracy is usually larger than what you see here. It's larger than the smallest movement you can create. That's actually theoretical. You may not really get this 0.1 thousandths. You think you moved 0.1 thousandths, actually maybe smaller